How do we see stars that are billions of light years away? I get this question every seminar I do, I believe. There's no question there's an awful lot of stars out there. The Bible says in Nehemiah chapter 9, Thou, even Thou art Lord alone. Thou hast made the heaven and the heaven of heavens. God created all the stars. There's an awful lot of stars out there. It's interesting, stars blow up every once in a while. They run out of fuel or whatever happens and they implode and then explode. It's called a nova, or if it's a big one, it's called a supernova. It seems that about every 30 years a star explodes. Well, after searching the heavens, they've only found 300 supernova rings. So the question would be, if the universe is millions of years old, why aren't there more supernova rings, the remnants?
Okay, no need to wonder. Just loaded up our question gun. Let's go answer hunting. Hovind is confusing supernova remnants, the expanding debris clouds that we can observe, with the total number of supernova that have ever occurred. These are completely different things. Supernova remnants don't last forever. They expand, cool, and eventually dissipate into the interstellar medium over roughly 10,000 to 100,000 years. After that, they are no longer detectable as distinct remnants. Hang on. They've merged with the background gas and dust of the galaxy. So the 300 remnants we observe aren't all the supernova that have ever happened. They're just the ones that occurred recently enough that that the remnants are still visible. The math actually supports an old universe. If the universe is billions of years old and supernova occur every 30 to 50 years in our galaxy, expected visible remnants would be between 300 and 3,000 based on the 10,000 to 100,000 year visibility window. Actual observed remnants is around 300, so it's about where we would expect it to be. This is just nonsense. Also, this is a really fascinating subject that I want to show you. Check this shit out. I don't know if you guys knew, but we can tell how far away stars are through many means, but one of those methods is by measuring the angle from Earth to that star, by looking up and looking at its angle, and then waiting until we go around to the other side of the sun, and then measuring the angle again, and doing a little bit of trigonometry, because we know that the Earth is this distance apart from this month to that month, and we know that the angle from the Earth to the star on this month is this, and then the other is that. And we can calculate pretty accurately how far away the star is. That's one way that we know, but check this out. We also know that when stars go supernova, they are a set brightness level, luminosity. We know exactly how bright they're going to be. And we use some of these factors to calculate roughly how far away they are and how big they are and stuff like that. Now listen to this YouTube short.
Take a look at this picture of stars.
Okay.
Are there any differences between them that you can make out?
Well, they have different colors.
Right. Anything else?
Some are brighter than others.
Yes. Color and brightness are really the only differences that we can distinguish between stars just by looking up at them. Because even though stars vary greatly in their actual size, from here on Earth, they all just look like points of light.
Right.
Now, importantly, how bright a star appears to us depends on two things: how far away it is and how much light it's actually giving off, what we call its luminosity, which is something we can easily calculate once we know the star's distance.
Okay.
So here's what I'm getting at. What if, just for fun, we organize stars based on these two simple properties, luminosity and color? We observed tons of stars and put them on a graph, placing the bluest stars towards the left, the reddest stars towards the right, the most luminous stars up top, and the dimmest towards the bottom. And voila.
I think he means voila, but okay, I'll take it.
Voila.
What we just created here, my friend, happens to be the most important diagram in all of astronomy. The legendary HR diagram. At a glance, this thing tells you everything you need to know about any star in the universe.
In what way?
Well, what you might have noticed is that stars don't just have any random combination of luminosity and color, but rather, when organized based on those two properties, they fall into very distinct groups. The vast majority of them fall on this roughly diagonal line, telling us that, in general, the brighter a star is, the bluer it is. And the opposite. The dimmer the star, the more red. Now, as it turns out, a star's color is directly related to its surface temperature. And this might be counterintuitive, but the bluer a star is, the hotter it is, and the redder the cooler. So, in most cases, hotter equals brighter, and cooler equals dimmer. But interestingly, some cool stars are insanely bright, and some hot stars are really, really dim. So what's the deal?
Yeah, what is the deal?
Well, perhaps the most profound thing that this diagram reveals to us is stellar evolution. It tells us how stars grow up, get old, and die.
How?
Well, it goes like this. When a star is born, how massive it is will determine where it initially takes its place on this diagram. And as the star ages, its position will slowly change.
Yeah, that's the end of it. I thought that was super fascinating. It kind of explains how we know how far stars are, what age they are, and their brightness, and everything. It's really interesting, I thought. The blue stars are smart and red stars are dumb. Makes sense, yes. Anyway. So yeah, all this stuff about Kent Hovind, to get back to the point, complete nonsense. All of it is complete trash.
Would be, if the universe is millions of years old, why aren't there more supernova rings, the remnants of these blown up stars?
There are about as many as we would expect there to be. That's just a lie.
That indicates only a few thousand years. Of course, the Bible says God made everything 6,000 years ago. And the textbooks say it's billions of years old. I think the textbooks have a problem because there should be a lot more supernova rings.
Nope, no problem.
Plus, obviously, you have a problem. Stars being born should equal stars dying, or else you're going to have a real serious problem. There are plenty of stars out there, but we've never seen one star forming.
Again, I just explained how we know that. That's just a lie. We've seen stars at all points in their life cycle.
We see stars blow up every 25 or 30 years. We've never proven the formation of one new star. One atheist I debated said, oh, Hovind, there's this new star forming right now in Crab Nebula and some of the different clouds out there in space. You see stars forming. No, you don't.
You simply do. I'm sorry. I disagree, good sir.
You see spots getting brighter. You are assuming
No, that's not what we see. Spots getting brighter. It's completely different.
a star is forming. But actually, all you're seeing is a spot getting brighter. It could be there's a dust cloud clearing and there was already a star behind it. Any fourth grade.
My God, dude. This guy hates science. He cannot fucking stand science, can he? You cannot accept when people come to true conclusions about things. Jesus fucking Christ.
Would know that. So nobody's ever proven the formation of one star. In Science magazine in '86, they said the silent embarrassment of modern astrophysics is that we do not know how even a single one of these stars managed to form.
Oh, give it a fucking rest. Yes, we do. We have a very clear understanding. The clip I played earlier was very basic and straightforward and simple. It was not like, we have way more information now. We have so much information on how this works that people teach classes on this. I mean, when I was in chemistry, I was majoring for chemistry for a while there, for like a year. Anyway, when I was in chemistry, we learned the equations, the chemical equations that take place in stars as they go to the center of the star and then come out further to the outside of the star. We learned about the equations that happen. We have a very strong grip on how all of this works.
Situation's no better now. Nobody can prove any star formed by natural processes. If dust tries to get together, as it increases in density, it increases the temperature, which increases the movement, and it drives it back away. It's called Boyle's gas laws. You cannot compress dust into solid matter without creating a real serious physical science problem of overcoming the gas laws.
Okay, hang on. Let's see if we can get info on this one. Okay, this is just a fundamental misunderstanding of the physics and the conditions under which stars form, apparently. Here's what he's referring to. Gas pressure naturally wants to push particles apart. This is true, but he's ignoring gravity, which is the dominant force at the scales involved in star formation. Here's what actually happens. Gravity overcomes gas pressure at sufficient mass. When you have enough mass concentrated in a region, typically in giant molecular clouds with masses of 10,000 plus solar masses, gravity becomes the dominant force. The gas doesn't need to violate any laws. Gravity simply overpowers the outward gas pressure. This is called the Jeans criterion, established in 1902. So we're talking 120 years old, this Jeans criterion is. 125 years or so. Initial density perturbations exist. Molecular clouds aren't uniform. Molecular clouds aren't uniform. They have density variations from turbulence, shock waves from supernova, spiral arm compression, and other mechanisms. Denser regions have stronger gravity, attracting more material in a runaway process. Cooling is critical. As gas compresses, it would normally heat up and increase pressure, which could halt collapse. So that's the bottom line. He's saying gas laws apply, but we're talking about like masses of clouds that are like 10 times bigger than the sun. And when you're dealing with masses that big, gravity takes over. That's the point. That's the bottom line here.
The pressure increases, the temperature increases, which drives them out again. It's not going to happen. One professor said, "Oh, Hovind, we figured if 20 stars explode near each other, they'll produce enough energy to squeeze the gas and make a new star." I said, "Well, sir, that's just brilliant. You know, you're saying if you lose 20, you can gain 1.
I mean, if you... Wait, I'm sorry. One more time? I missed part of it.
Stars increases, the temperature increases, which drives into solid matter without creating a real serious physical science problem of overcoming the gas laws. The pressure increases, the temperature increases, which drives them out again. It's not going to happen." One professor said, "Oh, Hovind, we figured if 20 stars explode near each other, they'll produce enough energy to squeeze the gas and make a new star."
If 20 stars explode near each other. No, nobody is saying that. They're saying basically if supernova explosion is one possible source of perturbation that could cause a collapse, but there's a lot of stuff that could cause things to collapse. It's like, you guys ever seen where you or what's it called? Where you super cool an item where it's, oh God, how do I phrase this? Where you put a beer in the freezer, but it doesn't actually freeze, and you take it out and you tap it on the table, and then it instantly freezes all the way up. Have you guys ever seen that? It's kind of like that process, what we're talking about here, I understand. Is it called super cooled or? Oh, dude. Oh my God. Alex O'Connor, get rid of that fucking mustache. I'm begging you. It is so bad. Oh no. I've realized Christianity is more plausible than I thought. What?
I talk about this and I debate this all the time, and I debate whether Jesus was God or whether he even claimed to be God and all of this kind of stuff. But for me, the undeniable thing is that there's this extraordinary historical...
What? No! Cosmic Skeptic, what is wrong with you? Oh, dude, this guy's been on my channel. I know people that are like, I know his best friend, and I've spoken to him many times, and he was kind of he came to one of my events to speak. Like, I invited him, and he came to speak at Faithless Forum multiple times, all the way from England, or whatever the fuck. He's a complete shithead, dude. I'm sorry. I don't like this guy at all anymore. He's a scumbag. He doesn't mean it the way it sounds. Okay, well, that's something. We may watch that. Anyway, so it was clickbait is what you're saying. Here you go. The camera work on this was superb. That was really, really good. Damn. Anyway, this is basically, from my understanding, what's happening with the stars. They are collapsing instantly as the result of any perturbation, anything that kind of kickstarts the process. It just, instantly all collapses in on itself, basically, because of the gravity involved in all of the dust nearby in that exact same way. So that's what Kent Hovind is probably talking about, if I had to guess. He's saying that the scientists are saying a supernova exploding is one of those things that can cause that process to kickstart where it wouldn't have kickstarted otherwise. It's not the only thing that causes it to kickstart, but it does happen a lot. There's a supernova nearby, and other gas clouds that are in the vicinity all collapse in on each other or on themselves because of the waves, the shock wave that happens, basically. That doesn't mean that 20 supernovas have to explode for one gas cloud to collapse into a star. And if, in fact, it could be one supernova explodes and 20 gas clouds collapse into stars. He's just trying to make it sound unreasonable by completely twisting it around, of course.
I said, well, sir, that's just brilliant. You know, you're saying if you lose 20, you can gain 1. Man, you ought to run for Congress and help those guys borrow their way out of debt. You know, that's a dumb idea. We've never seen it happen. It's purely theoretical that 20 stars could do that, but that is a losing proposition, not
That's just a lie. He's just lying here.
gaining. There are lots of stars. The Bible says God created the stars in Genesis 1:16. He created them to be lights on the earth. Psalm 147 says he counts the number of the stars and gives names to all of them. The Bible says he layeth the beams of his chambers in the waters, who maketh the clouds his chariot, who walketh upon the wings of the wind. It is possible that Psalm 104 ties in with Psalm 148, that there is still water above the heavens.
Oh, yeah. He insists that there's an ice dome around the earth, or there was, I guess, an ice dome around the earth that melted, and that's what produced all the water in Noah's flood. It's fucking insane, dude. It is insane.
Nobody knows what's beyond the stars, if there's an end at all. But it could be that this verse and verse of Revelation, where the Lord sits on many waters, is talking about the fact that there was a layer of water above the earth, and there may be another layer of water beyond the stars. Don't know. Just a theory, something to chew on. There's no way we could...
Just a theory, he says. Just a theory. A theory is the absolute peak of what any scientific concept could hope to reach. It's different from a colloquial theory, where people use that word casually when they really mean hypothesis.
Well, anyway. Okay. There's a lot of stars out there. It's been estimated that everybody on Earth could own 2 trillion stars to yourself.
Okay, I haven't heard that, but let me, why not? We'll check. 2 trillion stars. I mean, there are certainly a lot, but I just want to be sure on every single thing. It's him, obviously, trying to make the universe seem impossibly vast, to argue that it's impossible it could have come about on its own. Actually, I guess it's about 25 sextillion stars per person, or 25 billion trillion per person, not 2 trillion per person.
That's a lot. Million, billion, trillion. The stars are really far away. Hubble telescope focused in on a dot. They thought they found a black spot in space, about the size of a grain of sand, held at arm's length. They looked at that spot for 10 days, and in that one spot there were so many stars they'd never seen before that they couldn't even count them. That's just one spot, the size of a grain of sand, new stars just discovered. There's a lot of stars. Stephen Hawking, who hates Christians and creationists...
Oh, give it a fucking rest, dude. No, he doesn't.
...said, and won't debate me, by the way. Steve, I'll take on any time.
Because he wants that extra attention, of course.
He said, stars are so far away, they appear to us to be just pinpoints of light. He said, there's only one feature we can observe, that is the color of their light. So when you look at a star, you cannot see the size or shape of the star. All you see is what color it is. We assume that stars are like the sun, and the sun is like stars, but
that's not true. That's not accurate. Again, I played that clip earlier explaining how we know what we know. It's way more complicated than Kent Hovind wants it to seem. He's just fabricating this.
It's purely an assumption. We don't know that. Some people say, oh yeah, we can tell by the elements that it's burning. It gives a color characteristic, the signature, you can tell the elements.
I don't think, no, that's not what they say. Okay.
Evolutionists never talk about this, but they are, of course, assuming that even the molecules evolved in other places, just like they evolved on Earth.
No, molecules are the same everywhere. Like atoms are the same everywhere. Again, I learned about this in chemistry, how things, or the equations, the chemical equations that take place in stars from the center to the outer limits.
They're assuming the same 92 elements we have here will be the same found throughout the universe.
Bro, are you kidding me? You're telling me you believe chemistry is different 4 light years away. Chemistry just doesn't exist 4 light years away. Is that what you're telling me, really? Do you really believe that, Kent? Chemistry just doesn't exist as a concept elsewhere? What the fuck, man?
They've never talked about that, but you have a real serious problem if you just assume that the same molecular arrangement evolved, because molecules would have to evolve too, by your theory.
No, that's not true at all, actually. The fuck is he smoking?
I think is a dumb idea. Okay. I taught high school trig for many years as one of the subjects I taught. If you want to find the distance to an object you can't possibly touch, like a star, you have to measure it with what's called parallax trigonometry.
Yeah, I described this earlier. I'm not sure which part we're in, but you wait till I'll let him go. Go.
You have to know 2 sides and 1 angle, or 2 angles and 1 side, in order to calculate the distance to this unknown point, or to this unknown distance to this point, with simple sine, cosine, tangent. The problem is Earth is only 8,000 miles in diameter.
Yeah, but the Earth goes around the sun, a certain number of miles or whatever. We know this because we take an angle of a star in the sky, and then we wait 6 months to go around to the other side of the sun, and then we take that angle again, and we work it out and figure out roughly how far away it is. It's not good for things that are very, very, very far away. It starts to lose accuracy after a certain point. But stars that are, 4 light years away or whatever, we can tell pretty accurately how far away they are. The further away stars, they won't move anywhere near as much as the others do, is the problem. If a star is moving like a lot, then it might be an indication that it could be further away, or that it could be closer, I mean. Depending on or it could be an indication of how it's positioned or whatever other. I mean, there are a billion things that we have to account for when measuring this stuff. But let's listen to what he said here one more time.
Unknown point, or to this unknown distance to this point, with simple sine, cosine, tangent. The problem is, Earth is only 8,000 miles in diameter, which is basically nothing compared to star distance. So to find the distance to a star, you have to get your observers further apart to make a triangle that's, a decent angle. Well, they look at the star in January, then they look at the star in June, and they get a much bigger base on their triangle. This is Earth's orbit around the sun.
Right.
Well, it's 93 million miles to the sun, which is a long ways, but it takes light 8 minutes to get here from the sun.
That's correct.
It's called 1 astronomical unit. That is, the distance from the sun to the Earth is an AU, an astronomical unit. So we are 8 light minutes from the sun, which means the diameter of our orbit is 16 light minutes. That would be the diameter of Earth's orbit around the sun.
Yep.
This diagram here shows a little yellow dot on the far left. That would represent Earth's orbit, 16 light minutes. A year has 525,000 minutes in it.
Yeah, okay, I don't understand. That's why it's only useful for telling stars that are a little bit closer, but we can do this and judge how far a star is based on its luminosity as well, from supernovas and stuff like that, because supernovas have a set luminosity. We know how bright they're going to be.
That's a real skinny triangle if you did it to scale. It's like having two surveyors with, a telescope 16 inches apart, looking at a dot 525,000 inches away, which is 8 1/3 miles.
Yes, that's correct. Okay. This is math. Like I said, we can use math to come to calculations. Are you really unaware of this? This is the first time somebody is saying this to you, Kent? He's not listening.
You set that up and draw it out on a piece of graph paper, you find you got a real skinny triangle. It works out to be an angle of 0.017 degrees at the apex.
So, math is math. It doesn't matter if the triangle is 0.17 degrees or, I don't know, angles 170 degrees. Like, it's irrelevant.
I think you can have a hard time measuring something like that. If you want to...
No, it's measurable. It is perfectly measurable. It's called math. Really. Did he not? Why? What a stupid fucking thing to say. Seriously. You have a triangle that is very tiny. You're going to have a hard time measuring. No, you're not. It's the exact same equation, whether, whatever the shape or whatever the angle or whatever the fuck. What are you talking about, Kent?
Measure 100 light years. By the way, that was just to measure 1 light year. If you wanted to measure 100 light years, you'd have to move your dot 830 miles away, keeping your surveyors 16 inches apart. That's like having two guys on my roof here in Pensacola, Florida, looking at a dot in Chicago.
Again, the problem is not that we need to be looking at the dot clearly in a telescope. We don't even need to, we just need to know that the dot is there. We just need to be able to see the dot. We don't need to make out high def detail or whatever the fuck with a telescope. This is a math calculation.
If the guys are 16 inches apart and they're focusing on a dot in Chicago, that's a real skinny triangle, okay?
But it's a triangle.
Figuring 15 billion light years is clearly impossible.
15 billion light years? Is that what he said? Yes, that's correct. We can't find 15 billion light years with that method. We use other methods to find further things. And also, there are not 15 billion light year stars. I think the bubble that we can see around us is 14.3 or 13.8 billion light years or something. Furthest individual star we detected is Arundel, formerly WHL 0137-LS, observed by the Hubble Space Telescope and confirmed by James Webb. It's approximately 28 billion light years away. Really? Wait, Okay, the universe is about 13.8 billion years old, but that star is 28 billion light years away because the universe has been expanding the entire time the light was traveling toward us. When Arundel emitted the light we're now seeing, it was much closer to us, only about 4 to 5 billion light years away. But during the 12.9 billion years that light has been traveling through space, the space itself has been expanding, stretching the distance between us, where the star was, and where it is now, if it still exists. So it almost certainly doesn't exist anymore. So nothing can move faster than light isn't exactly true. Space can expand faster than light travels. I've known about this for a long time. Space can expand faster than light travels, which means we can have things that are further away than 13 or 14 billion years or whatever, but we are still getting the light from them. Also, the saying should be, nothing can travel faster than light inside space in a vacuum, because light slows down. It does not travel at 144,000 miles per second or whatever in water, for example. And you get a special type of glow when you look in the pools of a nuclear power plant chamber or whatever. Light is traveling through water slower than the actual molecules are, if I'm not mistaken. And it creates a kind of glow. What's it called? What kind of radiation? It's called Cherenkov radiation, a phenomenon that occurs because light travels slower in water than in a vacuum. Charged particles from the nuclear fission process move through the water faster than light can in that medium, creating an electromagnetic shock wave that appears as blue light. And it looks kind of like this, or like this. It's pretty cool, actually. Anyway, so light is not the fastest thing in the universe necessarily, and things can travel faster than light, like space, or molecules that are, going through a nuclear chamber or whatever, that kind of thing. I think that's fascinating. But back to how we know how far away these stars are. For something such as Arundel, we can't use simple methods like the triangle method. The measurement relies on gravitational lensing combined with redshift. Gravitational lensing, Arundel sits behind a massive galaxy cluster, WHL 0137-08, that acts as a cosmic magnifying glass, bending and amplifying the star's light by a factor of thousands. Without this natural magnification, we couldn't see an individual star at that distance. As the universe expands, light from distant objects gets stretched to longer wavelengths. Arundel has a redshift of Z equals 6.2, meaning its light has been stretched significantly toward the red end of the spectrum. This redshift tells us how the universe has expanded since the light was emitted. Cosmological models. We plug the redshift into our models of cosmic expansion, incorporating dark energy, matter density, etc., to calculate the actual distance. The cosmic distance ladder for closer objects. For progressively nearer objects, we use different techniques. Parallax, as we talked about, Cepheid variables, 100 million light years or so. We can use Cepheid variables for those. These stars pulsate with periods directly related to their intrinsic brightness. Compare known brightness to observed brightness to get distance. That's like supernovas exploding is a known brightness. It will always be this amount. Type 1a supernova, billions of light years. These exploding white dwarfs have remarkably consistent peak brightness, making them standard candles for measuring cosmic distances. So there's the answer. That's how we tell further away. This is my favorite Cherenkov. This is my favorite Cherenkov radiation short video. Audio's kind of loud. Let me see. That's cool. That's awesome, right? Damn. Really interesting stuff, how that works. All right, let's continue with this poor dumb fool.
It just can't be done. And I don't think you can tell exactly where you were 6 months ago on opposite sides of Earth's orbit. That would be a stretch also. Okay.
Yeah, but we can get a pretty accurate estimate of all of this stuff. And also, that's not the only way that we come to the determination. Like I said, there are a billion different ways. Luminosity, since, supernovas are the same brightness across the board, helps us tell, for example. It's just full of shit. He's just trying to poke holes in science for no reason. Just a reminder, I would really appreciate it if you guys checked out my Patreon. If you're not going to donate, you don't have to, but follow me there at the very least. owenmorgan.com/Patreon. Just in case something happens with the government or whatever. It would be really good if you had some way to connect with me and my content. I'm really concerned about that. And maybe you should consider that for other creators too.
This textbook says, parallax trigonometry can be used to measure distances less than 100 light years.
Yes.
I agree. Much less. I think you'd have a hard time measuring 20 light years, but I'll give them 100. I'll give them 500 for the sake of the argument. The fact is you can't measure...
But we don't want 500 because that's not how far it will measure. It measures 100.
A billion.
Sorry, step back.
The fact is you can't measure a billion.
You can measure a billion, but not with that, obviously.
I'm not saying the stars aren't that far away. They probably are. I'm just pointing out we have no way of measuring it. We don't.
Wait, yes, we do. And why are you poking holes in this then? If you agree that it's they exist that far away, what's the point of even poking holes in this?
I don't know how far away they are. If somebody tells you that star is 7.9 billion light years away, just say, how did you measure it? Was it a Stanley, a Lufkin, or a Craftsman? And who held the other end of that tape measure? Because I want to.
No, oh my God, dude, it's so fucking stupid. Gravitational lensing, red shifting, luminosity of supernova.
Meet this guy. It just can't be done. So number one, we cannot measure the distance to the stars. Number two, we don't know what light is. Is it a wave? Is it a photon? Is it a particle?
We understand exactly what life is. Light and life to some degree, I suppose. We understand exactly what light is. What the fuck are you talking about? We don't know what light is. This is probably partly the result of that stupid famous cartoon of the double slit experiment that made it seem like it was magical or something when it's not. Hang on. Wait 1 second. I'm just trying to find out here. Yeah, he's trying to exploit the wave-particle duality to suggest science is confused or unreliable. It's bullshit. So there was this cartoon about the double slit experiment a while back, and the double slit experiment basically says if you send photons or electrons through, specifically photons, we'll stick to that because it's easier. If you send photons through a wall that has two slits in it, it will shoot the electrons through, randomly, and it'll create on the back wall what appears to be an interference pattern, like when you drop two rocks into a lake and you see the ripples merge together. It creates that kind of pattern that looks like that. And that's something that only comes with waves. That doesn't happen with particles. So they didn't know if photons were particles or waves. So they get closer and they shoot like one at a time, like one every 5 seconds instead of, more rapid. And they record what's happening and watch basically what, which thing it's going through, which slit it's going through. And when they observed it, the interference pattern stopped and it just went through and landed in one of two positions on the back wall. So it started acting like a particle when it was observed. And people acted like this was mystical, like observation changes the universe. That's not true. What actually happened was the act of bouncing particles off of the ones that were going through the slits, which is what you have to do if you're going to observe it. You have to bounce particles off and then receive those particles again to see where the others were. The act of bouncing the particles off of it collapsed the wave function, and it acted like a particle again. It wasn't some mystical, supernatural observe and things collapse into blah, blah, blah. That's just garbage. It's complete bullshit. But here's what we know. Light exhibits both wave and particle properties depending on how we observe it. This isn't confusion, it's quantum mechanics, and has been well understood since the 1920s. Light is fundamentally a quantum object that doesn't fit neatly into classical categories of wave or particle. The wave-particle duality applies to everything, though. It's not just light. It's electrons, atoms, even molecules that show wave-particle duality. We use this understanding to build electron microscopes, transistors in computer chips, lasers, LED lights, all kinds of shit. If our understanding were fundamentally wrong, none of this technology would work. Hovind's implication is scientists can't even tell us what light is. How can we trust them that the age of the universe is, 14 billion years or whatever, or that evolution is real and accurate? He's trying to seed doubt when there doesn't need to be any doubt. We understand this perfectly well. And even if we didn't, I don't know is an acceptable answer. God created everything last Thursday to appear as though it was 14 billion years old. That's not an acceptable answer. It's nonsense. But is the cat alive or dead? I believe that we've determined that nature does not collapse into a decision the moment that it needs to. I believe we determined that these things really do take place, that causal events really do happen. Does a tree make a noise when it falls in the forest? Yes. Is the cat alive or dead? There is an objective answer to that, even if we don't know it, I think is what we have found. It was an interesting thought experiment that was hotly debated for a long time, but I think we've come to a conclusion about it. So, yeah.
I mean, it behaves sometimes like waves, sometimes like energy. Nobody knows for sure what light is.
We know pretty well what light is.
What it does, and we use it all the time, obviously, but nobody's ever defined what light is very clearly.
No, I think they have.
So, the entire principle or concept behind a black hole is the idea that light can be attracted by gravity. Well, if light can be attracted by gravity, if black holes exist, which nobody's proven that either.
Are you fucking kidding me right now? The dude doesn't believe that black holes are real now? What? This gets fucking crazier and crazier as we go. What are you talking about right now? Seriously, what the fuck? I'm sorry, this is a lot.
But then the speed of light can't be a constant. At Harvard University in '99, they slowed light down to 38 miles an hour.
Again, the speed of light is the speed limit of the universe in a vacuum. It is not the speed that light travels in all circumstances, in all mediums or whatever. And things do move faster than light, particularly, namely, space itself. So, yes, obviously, you're poking holes in things that we already understand and that we don't need holes poked in or whatever. Like, what the fuck?
The next year, they slowed it down to 1 mile an hour in the year 2000.
I don't know about that, but maybe. Like, okay, I have no emotional tie to this. It doesn't prove or disprove anything at all. What the fuck?
In the year 2000. The next year, they brought it to a dead stop. They took light and absolutely stopped it. This was done at Harvard, it was done at Smithsonian, and it was done at Cambridge. And by the way, that's how science works. An experiment should be demonstratable, repeatable, testable.
I think the word is demonstrable, but yes, I agree, absolutely.
Evolution is none of those. Nobody's ever demonstrated or tested or proven any of it. It's all in the mind. They think it happened. It's not science. Okay.
It's simply false.
At Princeton University in the year 2000, they speeded light up to 300 times the speed of light. Why would the speed of light be an unbreakable barrier?
Wait a second. Let me see if we can find some info on this. Let's just copy it. Eureka, scientists break the speed of light. That doesn't sound right. I'm suspect. And he even linked to the New York Times. See, also the New York Times, May 30th, 2000. How many New York Times articles released on May 30th, 2000? That doesn't tell us what we're looking for. He didn't even give us the title of the article. He just said, see New York Times, May 30th. Okay? All right, here we go. The research by Dr. Lejun Wang at NEC's Princeton lab did demonstrate something interesting with light pulses, but no information or matter traveled faster than the speed of light. This is a crucial distinction Hovind either doesn't understand or deliberately obscures. Here's what happened. Wang's experiment involved group velocity versus phase velocity. What appeared to exit the cesium chamber before it entered was the peak of a light pulse. But this is an effect of how the pulse was reshaped by the medium, not actual faster than light travel. Think of it like this. Imagine a wave traveling down a rope. You could manipulate the rope in such a way that the peak of the wave appears to move faster than the wave itself is propagating, but no actual information traveled faster. this doesn't violate Einstein's theory of relativity, because the speed of light that cannot be broken in relativity refers to the speed at which information can travel, the speed at which causality propagates, and the invariant speed c in spacetime. Wang's experiment violated none of those. The researchers themselves were clear about this in their actual papers. Like, where did he even hear about this? Where did he even find information on this to kind of twist it around in the first place? It's wild.
Barry Setterfield, Australian astronomer, did a lot of work on the speed of light question. He says, the speed of light has decreased. He said in the last 300 years, at least 164 measurements of the speed of light have been published, 16 different ways it was measured.
Oh, give it a fucking rest, bro. Really? You think the speed of light is changing? I mean, I assume he means the constant in the universe, right? The c, not just the speed that light travels, but the cosmic speed limit itself. Barry Setterfield is not a mainstream astronomer. He's a young Earth creationist, that's the source here. Barry Setterfield. He's a yekker who cherry-picked historical measurements to support a predetermined conclusion. His work has been rejected by peer review and widely criticized. So this is just nonsense. This is nonsensical lies. What he's showing on screen here, it's complete trash.
He said the speed of light has apparently decreased so rapidly that experimental error cannot explain it. Here's a chart showing that the speed of light has declined in the last 150 years.
This is just a lie. It is not the speed of light in all circumstances. It's just the maximum speed that information can travel.
About 1960, the chart seems to level off, and everybody since about 1960 has gotten the same number. If you measure the speed of light today, you're probably going to get 186,282.
I'm sorry, 186,000. Why do I keep saying 140,000? Is that what I said? 186,000 miles per second. Aside from that, you don't think that it's more likely that the measuring technique was inaccurate rather than the actual speed of light? You didn't knock that possibility around? What the fuck?
Something miles per second. Okay, that could be because in the late 50s and early 60s, they began using the atomic clock to measure the speed of light. And the atomic clock uses the wavelength of a cesium-133 atom, which means you're using light to measure light.
Oh my god, it's so fucking stupid. I don't think that the cesium atom is measuring, I don't think that that's measuring light. I think that's measuring the speed of decay or what, hang on, let's see. Atoms are not photons. Photons are not atoms. But let me just get some info on this to be sure. Why is he even trying to poke holes in the speed of light in the first place? It seems like his reasoning is just to invalidate science as a whole. Atomic clocks do not measure light with light. Atomic clocks measure time based on frequency of electromagnetic radiation emitted during electron transitions in atoms, like cesium-133. They're measuring the oscillations of electrons, not measuring light. The atomic clock provides an extremely stable time standard. Then you measure how far light travels in that time interval using physical distance measurements. Here's how modern light speed measurements actually work. Distance is measured independently using physical standards like meter bar or later wavelengths of specific light sources. Time is measured using the atomic clock. Speed equals distance divided by time. This isn't circular reasoning. You're using an independent time standard to measure how fast light travels across an independently measured distance. The real reason for the 1983 redefinition, the speed of light became so precisely and consistently measured, the scientists realized our ability to measure the speed of light had become more accurate than our ability to define the meter. So they flipped it, defined the speed of light as exactly 299,792,458 meters per second, and redefined the meter based on that. This wasn't because measurements became inaccurate. It was because they became so accurate and consistent that it made sense to use light speed as the standard. This is just complete nonsense.
You have a rubber ruler. Of course, you're not going to see it if it's declining. It may be we're on the tail end of a logarithmic digression, or it simply may be we're using a rubber ruler by using an atomic clock to measure it. There's a couple articles.
The atomic clock is a rubber ruler.
Showing about how that the speed of light was apparently exceeded by a factor of as much as 100. Clear back in 88 and 95, there were articles published about this. The speed of light is not a constant.
Speed of light is not a constant, but the speed that information travels through the universe is a constant and cannot be broken.
The Radiophysical Research Institute in Russia, the cosmologist there, said the speed of light was 10 billion times faster at time zero. Astrophysics and Space Science magazine, 1987. According to the Big Bang Theory, the speed of light had to be much faster initially. There's an article from 2001, Science News, saying about the speed of light may have changed over history.
All right, no need to wonder. Just loaded up our question gun. Let's go answer hunting again. News articles showing different. I don't know if this is accurate, but I can say that space expands faster than light, or it's capable of expanding faster than light. And light is in space, which means that light is being carried along with space at the speed that space is expanding, and it's also emitting, or the light is moving at its normal fast speed in the first place, and that is how light can move faster than the speed limit of the universe of like 186,000 miles per second or 300 million meters per second. Regarding these news articles, there are legitimate, though speculative, theories about the speed of light in the very early universe, like variable speed of light cosmology, VSL, proposed by physicists like Magwagio something, or John Moffat. Inflation theory is another thing that's Alan Guth, I think. That's pretty solid. But Hovind is ignoring some critical distinctions. These theories are about conditions in the first fraction of a second after the Big Bang, not about the light speed changing over billions of years or during human history like he's pretending here. Nonsense.
Study says. Imperial College in London, the man wrote an article and said a shocking possibility is that the speed of light might change in time during the life of the universe.
Complete bullshit.
At Rutgers News Service put out an article from Sydney about a team from Australia that said the speed of light may not be a constant in August of 2002. It says the speed of light can change.
Again, light changes. The speed that light moves changes, but the speed limit doesn't change.
The speed limit of the cosmos is being questioned.
No, it's not.
September 2002. So, there's a book out called Faster Than the Speed of Light, and I'm sure this fellow who wrote this book will be persecuted for daring to suggest such heresy as this.
Oh, please. God, he's a perpetual fucking victim, these people are.
Discover magazine ran an article about this. Was Einstein wrong about the speed of light? A recent article saying Einstein was wrong.
No, he wasn't. Oh my God. What the fuck, dude? Seriously, why is he doing this? This is insane. I'm sorry. I have to take this one down too. This is fucking wild. He's been doing this for like 2 minutes, right? 29. Einstein was wrong of relativity. Speed of light keeps changing. It's not constant. What was that? That was 20. And then 29, 30. This is just insane to me.
The speed of light is not a constant. So, I don't think we can prove what light is, and I don't think we can prove light's always traveled the same speed. Number 3. The creation was finished when God made it. It's interesting, Jesus made wine out of grapes that never existed. Turned water straight to wine. Where's the grape stage? He can make a full-grown man out of the dirt and then make a woman out of his rib.
So you're telling me that you are describing something that's fucking insane and unreasonable and nonsensical. And you're telling me I should believe this because God does nonsensical, irrational, insane shit all the time. Is that it?
Make animals out of the dirt. He can make the earth out of nothing. Jesus.
Wait. I'm sorry. The Bible didn't say God created the earth. It says the earth already existed when he came along. In the beginning, God created the heavens and the earth. Now the earth was formless and empty. Darkness was over the surface of the deep, and the Spirit of God was hovering in the waters. That's what Genesis 1:1 says. However, if you read Bart Ehrman, he explains that the opening verses in Genesis indicate that the earth was already here. There were already waters when God arrived, and he created like the land and everything else. That's what that verse actually means.
Just made enough to feed 5,000 people out of a little boy's sack lunch. We're always trying to limit God. I get real worried about folks that try to put human limitations on God. God didn't make two babies.
I'm not trying to put human limitations on him. I'm trying to fit him within logic. Something can't both be false and true simultaneously. That's a paradox. God cannot be paradoxical, I imagine, right?
babies and put them in the Garden of Eden and hand them a package of seeds and say, here, plant these quick. You're going to need supper. He made a full-grown man and a full-grown woman in a full-grown garden. That's the only way it's going to work.
He didn't make two babies in the garden. He says that's the only way it's going to work. What? I thought he was God. He can do anything, can't he? Isn't he capable of accomplishing literally anything? What happened to all that?
Number 4 thing to consider. A light year is a distance. It's not a time.
Right.
It's a distance. It's the distance light can travel in a year at today's speed. A light
At today's speed. Fucking give it a rest, dude.
year could be done in 1 second if you speeded the light up.
Oh, give it a fucking rest. It's the speed that light travels in a vacuum through space. And he cannot wrap his head around the fact that light travels, that there are things that are further than 14 billion light years, or more accurately, there are things further than 6,000 light years away. He cannot grapple with that, which means the Earth is older than 6,000 years. He really is making the argument at its core that the Earth was created last Thursday to look like it's 14 billion years old, or that the universe is 14 billion years old. That's the argument that he is making right now.
It's simply a distance. It's like so many gazillion miles. I think 6 trillion miles is a light year. Okay, number 5. Since the speed of light is not proven to be consistent, why would star distance have anything to do with age of the universe?
Wait, it is consistent. You gave us examples of how they can slow light down in other mediums, but when it travels through space, it's a uniform speed.
Some people say, oh, wait a minute.
Well, I'm sorry. Yes, when it travels through space, it's a uniform speed. Through space and in a vacuum, it is a uniform speed.
Some people say, oh, wait a minute now. I know we can't measure the distance with triangulation, parallax trigonometry. What about measuring with Cepheid variables or redshift? That's the other way they try to do it, and it also loaded with flaws in the theory there. The redshift is the idea that when light goes from a star, the red is shifted over. They look at the light through a spectroscope, and you'll see black lines on there, and the black lines are shifted toward the red end of the spectrum. You get the normal spectrum, red, orange, yellow, green, blue, indigo, violet.
Wait, I'm sorry. Black lines? I'm not sure I understand what the hell he's talking about.
Red, orange, yellow, green, blue, indigo, violet. But the black lines are shifted red. And
the black lines are shifted red? What the hell are you talking about? The black lines are shifted red? What does he mean by that? Yeah, this is the Doppler effect for light, basically. Red shifted. And that's how we know how far the furthest things are away. The redshift and gravitational lensing.
By the way, guys, check out my new shop, owenmorgan.com/shop. I have a bunch of really cool designs on there.
Wow, this is proof. The star is receding. It's moving away from us.
No, partially. There's a difference between a red star and, say, a red galaxy or a red shifted galaxy where everything in the galaxy has a red shift. You know, we can look at a star and zoom real far in and look at it turning red, blue, red, blue, red, blue, red, blue as the planets circle around it, because planets are not circling the sun, really. The sun and the planets are circling a common point. It's just that that common point is inside of the sun. So the sun has a wobble as well. It has an orbit as well. Everything is circling everything else. You know, gravity doesn't even really exist exactly. It's really the warping of space-time, I understand. According to Einstein, it is the warping of space-time. It's like dropping a big ball on a trampoline. Now everything is attracted to where that ball is because it's bending the fabric there, and everything is falling toward it. It's identical to how that works.
That could be. I don't know.
I don't know, he says, really.
Star is receding. It's moving away from us. That could be. I don't know. But there might be other ways to answer this. This is called the Doppler effect. If a train is coming toward you, it squeezes the sound waves in as the train makes noise, and you hear it drops pitch as it goes past you. It's called the Doppler effect. If you're going past the sound source or the sound source is going past you, either way, it works the same. Sound is called compressed coming in and refracted or stretched going out. Well, they thought possibly if the star is coming in, it would squeeze the light waves, whatever light waves are, and make a blue shift. If the star is leaving, it would...
They didn't think that. That is measurable and factual. That is how the universe works.
Make a redshift. And so when the redshift was discovered years ago, they looked around the heavens and found most of the stars are giving a redshift. And they said, wow, this
I don't think most of them are giving red shift. We can measure the red and the blue shift, and it changes.
proves they're leaving. No, it doesn't, but that was the assumption. And then they said, if all the stars are moving away, that proves there was a Big Bang. That was the evidence for the Big Bang theory, the red shift. Talk about a lack of logic. But
That's not true. That's not the evidence for the Big Bang. We use cosmic microwave background radiation as one piece of evidence. The Big Bang is about as solid as it gets. It is unequivocally and beyond question absolutely true that the Big Bang took place, and it is measurable. Like, what the fuck, dude? It's so strange how he argues shit.
that's what they said. Okay. This fellow says there was an early sign that redshifts reliably indicate the distance of galaxies. For quasars, however, the diagram shows a wide scatter in apparent brightness at every redshift. He said, in fact, there is little correlation of brightness to redshift at all. Either quasars come in an extremely wide range of intrinsic luminosities, as most people believe, or the redshifts do not indicate distance. Sky and Telescope, December 94.
No, redshifts don't indicate distance. They indicate speed or direction. I'm sorry, direction is probably more accurate. They indicate direction. Let me just little correlation of brightness to redshift at all, either quasars. The quote appears to be accurate. The article, A Catalog of Quasars Near and Far, by Jeffrey Burbidge and Adelaide Hewitt, was indeed published in Sky and Telescope, December 94, page 32. The quote itself appears to be real. However, here's the critical context Hovind is hiding. Jeffrey Burbidge was a fringe figure who rejected mainstream cosmology. Sorry, I lost my place all of a sudden. Where did it go? Here it is. Burbidge was a respected astronomer in many areas, but he and his collaborator Halton Arp held deeply contrarian views about quasars that were rejected by the astronomical community. They advocated for intrinsic redshift, the idea that quasar redshifts don't indicate distance. This is a fringe position even in 94, and had been thoroughly debunked since then. How did Kent Hovind even find this? Like, this is such an esoteric, bizarre, tiny little thing. I don't understand how he even came across something that was debunked like nearly immediately and completely ignored by the rest of the scientific community. It is so strange to me how he finds this stupid shit. The issue has been resolved since 94. Modern evidence completely contradicts Burbidge's hypothesis. Since 94, astronomical research has found thousands more quasars showing the same redshift distance relationship, discovered high redshift galaxies, not just quasars, matching expectations, observed gravitational lensing of quasars by foreground galaxies, proving distance relationships, used quasars successfully as cosmological distance indicators out to redshift Z-7, found that quasar UV and X-ray properties don't evolve with redshift, confirming they can be standardized. So Hovind is just completely full of shit here in every single way. It's all a fucking lie with this dude. It is wild to me that he so brazenly, blatantly lies to your face like this.
Same magazine said, thus, for the only conclusion that can be drawn is that at least some quasars are relatively nearby, and a large fraction of their redshift is due to something other than expansion of the universe.
Not true.
So somebody tells
proven unequivocally false.
you we know the distance to stars because of redshift, say, I'm sorry, that is simply not correct. We don't know the distance because of redshift. Get the book, The Evolution Cruncher, from our ministry. It's $5 for a 900-page book. Excellent book, loaded with stuff.
Again, we know because of redshift and gravitational lensing. Redshift and gravitational lensing, both. It's not just one.
On creation evolution, he's got a whole section about the Doppler effect and the expanding universe. The Science News 95 said, another set of observations indicates that the universe appears to be 8.4 to 10.6 billion years old.
No, it's, I believe, 13 or 14 billion years old.
The new work relied on the Hubble Space Telescope to obtain distance to faraway galaxies. A team led by Tanver at the University of England used a two-step method to estimate the Hubble constant. I always get a kick out of that. Here they've got an equation which involves a number that you're going to multiply, like an algebraic equation, and they can change that number. They call it a constant, but they change it all the time, okay? I taught algebra for years. I'm telling you, you change one letter in an equation or one value in an equation, you change the outcome.
Uh-huh. Yeah, that's how math works. First time?
That's why they're always getting wild numbers for the age of the universe, because the Hubble constant is not a constant at all. Okay.
Hang on. Different values for The Hubble constant is measured, not chosen. Hubble constant isn't something scientists pick to get a desired age. It's an observed property of the universe, the rate at which the universe is expanding. Scientists measure through multiple independent methods. Local distance ladder, using Cepheid variables, type 1a supernova, and other standard candles. Cosmic microwave background radiation from early universe observations, Planck satellite. Anyway, gravitational waves from merging neutron stars, time delays in gravitationally lensed quasars, tip of the red giant branch measurements. There is real scientific tension with the Hubble constant, but it's not like as low as he wants to portray or as he would need it to be for his worldview to make sense. Everybody pretty much agrees on a range of roughly what the Hubble constant is, which is used to calculate the age of the universe. That's the bottom line here.
Let's go on here. He said, first they observed a type of standard candle, stars known as Cepheid variables, to find the distance to the spiral galaxy M96. He said you have to be very careful about drawing conclusions because of the Hubble constant, because measurements have huge systematic errors.
Okay, who said this? You didn't even tell us who said it. Who the fuck are you talking about? Who said this?
You change the outcome. That's why they're always getting wild numbers for the age of the universe, because the Hubble constant is not a constant at all.
Who is they?
Okay, let's go on here. He said first they observed a type...
Who is he? I don't know who the fuck he's talking about. Did I miss something? It just says Science News, September 9th, 1995.
Type of standard candle, stars known as Cepheid variables, to find the distance to the spiral galaxy M96. He said you have to be very careful about drawing conclusions because of the Hubble constant, because measurements have huge systematic errors.
You mean it will create systematic errors if you get the Hubble constant incorrect? Is that what he meant when he said that? Yes, obviously. If you run a math equation with an error in it, you will get a completely different value than you expected. Of course, obviously, yes. Is that what he's saying? And by the way, why did he put brackets in? You have to be very careful because of all of the measurements have huge systematic errors. I don't understand.
Astronomers believed the Veil, one of the best studied supernova remnants, was 2,500 light years away and 18,000 years old. They were quite wrong. In fact, the Veil is only 1,500 light years away and 5,000 years old.
Okay, let's find out. Okay, I found the answer. Wow, this one is actually complicated. The bottom line with this is that scientists did revise the distance and age estimates for the Cygnus Loop/Veil Nebula around 2000 to 2001. This is science working correctly. We find more accurate numbers as we go. That's correct. Original estimates had it at 18,000. We revised and got 5 to 8,000. However, we revised again back to 10 to 20,000 years after using new distance measurements and new, other types of measurements. So yes, we revised our estimates. That's how science works. Does that surprise you?
Discover magazine, January of 2001.
The Discover Institute, if this is who he's referring to, is a fucking joke. They're absolutely terrible. It's some creationist garbage.
An article about Rip Van Winkle showing stars are much younger than they thought. The article, University Around Us at Cambridge University, said even the nearest Cepheids are so remote, it's difficult to determine their absolute distance with any great accuracy. All large distances in astronomical literature are subject to an error of perhaps 10% from this cause alone.
I don't know if that's true, but even if it were, so even an error of 10% is not an error of 99.6%, which is what it would have to be if Kent Hovind were correct.
He said, we know that faintness, how bright the star is, arises from two causes, distance and absorbing matter in space, and it's generally not possible to apportion it between the two.
Right, so he's trying to poke holes in the luminosity, the standard candle thing, where supernovas are roughly an equivalent brightness no matter where they are. Let me just get some info on this one. This says Jeans James, The Universe Around Us, from New York Cambridge University Press, 1969. I'm not sure why we're taking a source from 1969 all the way in 2006 when he did this. Seriously, this is from 1969. What was the time difference? That was 45 years, 48 years already, almost 50 years when Kent Hovind released this, and now it's 75 fucking years. The book is, I'm sorry, wait a minute. This is my mistake. I made a mistake. This book is from 1929. This is an incorrect date on his slide. It's from 1929, not 1969, 1929. That's fucking wild. He's citing something from 1929 as evidence. That is wild. And it was revised in 1944, the book was. The 1969 date is just a reprint of the old edition by Cambridge University Press, apparently. That is crazy. James Jeans died in 1946, so he literally couldn't have written anything reflecting post-1946 astronomy. Seriously, how the fuck did Kent Hovind even find this quote? Like, some dude from 1929 who wrote some random book back then. This quote reflects 1920s to 1940s astronomy before we understood the cosmic distance ladder, refined in the 50s to the 90s, multiple independent distance indicators, spectroscopic techniques for measuring extinction, space-based observations, Hubble Space Telescope, etc. The problem was solved decades ago. Methods to measure dust extinction include color excess, spectroscopy, infrared observations, polarimetry, X-ray observations, multiple wavelength photometry. I mean, we have a billion, literally just like 50 different things that we can, like different ways that we measure this shit. I mean, it's just like, for that matter, how does Hovind know that they're stars in the first place? Really, I mean, he's taking a lot of things for granted while trying to poke holes in shit that, like, for no reason. Think about it. How does he know that we live close to a star, that the sun is a star? How does he know that it's not a gigantic black blanket that's been, like, thrown over us? And then, you know, you remember when you were in school and they had that big tent, or that big, like, I don't know what you call it, that tent thing, and you throw it up and then you pull it back behind you and you sit down on it. All the kids sit down on it and you're in this little enclosed dome or whatever. You guys, did you guys do that in school? I did that. Anyway, how do we know it's not one of those with holes poked in it? How do we know that's not what we're looking up at in the sky? We know that because of science. But how does Kent not know that? Because he rejects all the science that explains how we know what we know and about all the stars and everything. The parachute. Yeah, maybe it's the parachute thing. Yeah. This is just fucking wild, dude. 1929.
Possible to apportion it between the two. Get the book The Evolution Cruncher and find out what happened to Halt and Harp, who dared to question the redshift theory. Good way to lose your job. There's discrimination against those because they're looking for it.
Good. There should be there should be discrimination against people who don't understand or refuse to accept how the world works around them. There should be intellectual discrimination against those people so that they don't find themselves in a position in life, in a place where they can impose those fucking bullshit beliefs on our children. They should be nowhere near children. Okay, in fact, maybe we should create, like, no, I won't go. I was going to say maybe we should create a registry of young Earth creationists to prevent them from being anywhere near schools, but we'll avoid that. Anyway, the point is, these people are so completely full of shit, and they're fucking victims, constant victims. Really, get a grip on reality, Kent. You aren't the main character of the story. Creationists are not the main character of the story. You're not being fucking persecuted.
Looking for anything to hang on to this dumb Big Bang Theory is the problem. Big Bang Theory is a dud. Fred Hoyle said that 30 years ago, or 20 years ago.
Okay, well, even if he did say that 20 years ago, that was 20 fucking years ago, okay? Like, we've made a lot of advancements in 20 years.